Hello everyone, welcome back to MGF1106. So in this video we will be talking about the metric system for area and volume. So last time we already talked about the metric system for length. So I'm gonna put this one as the first Roman. Okay, this is the first Roman, and now for the second Roman we're gonna deal with the metric system for area. Okay, metric system. So this area metric system, so I'm gonna put it that way. Area, okay, metric system. Okay, now let me start the area metric system over here by giving you a square. So I have a square like this. Okay, a square. Okay, and I'm gonna divide this square over here into a subsquare. So let's say it has something like this. Okay. Okay. Now, if you go ahead and start counting, you will see that we have 1, 2, 3, 4, 5, 6, 7, 8, 9. So we have totally 9 subsquare. And let's say the length for this one of the side here is 3 meter. Okay, so each square, its length over here, its sub length over here represent by 1 meter. Okay, represent 1 meter. So over here we also have 3 meter. So the area of this square over here is actually is the value after we count all the subsquare over here, the total number of subsquare over here. So the area is the surface area is actually 9, right? 9. And 9, how we get 9? So 9 is actually come from 3 meter, 3 times 3, because if you look at this direction, you have 3, and you look at the vertical direction, you have another 3. So actually 9 is 3 meter times 3 meters, which is give you 9 meter times meters. We know meter times meters, so meter times meters is meter square. We already know that meter is the length unit. We already talked about in the previous video. So 9 meter square. So meter square is the unit, is the international, the SI unit, for area. Okay. Now based on the prefix table we had last time, you may remember we had a prefix table we had last time over here. Let's see, let me pull it out. Okay, so this is the prefix table we have last time, and based on this the prefix table, we can go ahead and create the metric system for area. Okay, now again, I'm gonna go. I don't think I should create the table for jota and zeta or exa, so I'm gonna just stop at peta. Okay, and I go from I think I have enough space, so let me go ahead and create the whole table for all of them. And now instead of meter, we're gonna have meter square. So for the area, so over here again we will have meter here, we have meter here. Okay, we have meters here. But now we're gonna go ahead based on this prefix table, we're gonna have create the metric system for area. So the first one we will have is jota meter square. So we're gonna put this zeta with y meters square. Okay, that's the first one. Then we have zeta meter square. All right, because the area, so everything, all the unit would have a square. Okay, this is the reason I'll explain it. Then we have hexa meter square. Then we have beta meter square. Then we have tera meter square. And then we have giga meter square. Then we have mega meter square. Then we have kilometer square, hectometer square, decameter square. Okay. Then we have meter square as the reference one. So let me use the another. So we have meter square. Then we have decimeter square. Oh, I don't know if I have enough space or not. Decimeter square. Then we have centimeter square. Then we have millimeter square. And then we go all the way down to micrometer square. Then we have nanometer square. We have picometer square. And we have femtometer square. So I don't have enough space here. Okay, so I'm gonna just stop at femto, but we also have antometer square, we have jeptometer square, we have joctometer square. Alright. Now, what's the difference between the area metric system and the length metric system? Last time, look at the length metric system. So we have length metric, length unit meters. So the way I put this later. So we have a length metric system. You see that for each column, okay, except for the micro, we have only 1 0. Okay, we have only 1 0. So for the micro here, we have a 6 0. Now for the area unit, meter square, area metric system. So for area metric system, we will have 2 0 for each column. 2 0 for each column. Okay, so think about this. Okay, so I'm gonna put over here. Okay, this is 1 for this column over here. I'm gonna draw the column. Okay. So we're gonna use meter square as the reference column. So this is 1, 1, 1, 1, 1. So for each column, so last time we got from meter square to decimeter square, we have only 1 0. But now for each column, for each unit over here, we go by 2 0, not just 1 0 anymore. Okay, we have to do 2 0. So we will have 0 0 for decimeter square. So it means what? It means that 1 meter square is 100 decimeter. It's not 10 decimeter anymore, but it's 100 decimeter square. Then will be 10,000 centimeter square. Then will be 1, 2, 3, 4. Then will be what? Then will be is that 100 times? It will be 1 million meter square. But by the how about micrometer square? So last time we know that 1 meter is 1 million is 60 micrometer. 1 meter is 60, so we 1 million micrometer. So now for micrometer square, you will have how many of them? So it will be 1 million is it means that, so this one right here, 1 million is actually, this one is 10 to the 6th power, right? So this one right here is actually 10 to the 6 power. Let me write over here. So this is 10 to the 6 power because there's 6 zero. Okay. But for micrometer square, you will have 10 to the 12 power. You see that? That's a lot, right? And for the nano is like last time we have how many? Last time we have 1 billion, right? So we need 0. But now for nanometer square, you will have 18 0 after what? After number 1. So you see that's a lot, right? That's a lot of 0. Let me write carefully here. And for pico is the like last time we have a trillion. So that is like 12. So if you go from 1 meter square to pico square, could be 24 0 after number 1. That's a lot. Okay, that's a lot. So it will be 24, and you keep double the number of 0 for femto, for anto, for jepto, and for jocto meter square. Okay. All right. Now, how about we go this now? How about the relation between the reference area unit and related to this one, this unit? So I'm gonna just go ahead and start with the tera. So for the tera, so you see the tera is 10 to the 12, 10 to the 12 meter. 1 terameter is 10 to the 12 meter. So it means what? It means that 1 terameter square. 1 terameter square is actually 1 terameter square. So let me write over here. 1 terameter square is actually 10 to the 24. Okay, it will be 10 to the 24. You double that meter square. That's crazy, right? That's a lot, right? And for the giga, so it will be 10 to the 18 meter square. I don't have enough space to write all the 0, so I'm gonna just go ahead and write it like this. And for the mega is 10 to the 12, 10 to the 12 meter square, and kilometer will be 10 to the 6 meter square, because we know last time 1 kilometer is 1,000 meter. So if you double the number of zeros, so we have 3 0, you have 60 meter square. Okay, then 1 hectare will be 10 to the 4 meter square, and so on. Okay, so that is how you go from the left side to the right hand side. Now, what if you want to go from the right hand side to the left hand side, which is I believe in the last video I forgot to mention. You're gonna do the same way, but you're gonna put the negative as the exponent. Okay, so for example, if you want to go, okay, let's say what do you want to go from decimeter? You want to go from decimeter, or how about centimeter? You want to go from centimeter square to meter square. Okay, so 1 centimeter square is actually 10 to the negative 4. 10 to the negative 4. Okay, so 10 to the negative 4 meter square. Okay, for 1 centimeter square, we go backward, we go this direction. Okay, so it means what? It means 1 meter square. 1 meter square is 10 to the negative 24 terameter square. Okay, so remember, if you go from left to right, it will be positive exponent, but if you go from right to left will be negative exponent. Remember that, okay? So I'm gonna put it over here. I'm gonna put over here. Let me see. So if you go from right to left, okay, if you go from left to right, then you have positive exponent. But if you go from right to left in this metric system, area metric system, you go from you will have negative exponent. And this rule is also true for the length metric system. In the previous video we talked about. Okay, if you go from from the left column to the right column, we have positive exponent. But when you go from right column to the left column, we will have negative exponent. Okay. Now let me start with our first example here. Example number 1. Let's see we have any example here. Okay. Okay. I cannot find any example here. Okay. I just go ahead and create an example for you. Convert 2.5 2.5 how about we go from 2.5 kilometer square to micrometer square. Okay. So we're gonna go from left to right. So it means that we will have a positive exponent. If you want to write in exponential form, if you don't want to write in exponential form, so it means that you have a bunch of zero on the right hand side of the final answer. So okay, so we go from kilometer. It means you start from this column right here, and we jump to micrometers right here. So let's see how many zero we have. So we're gonna put 2.5. So let's see how we do this. Okay. So let's go ahead and draw the table. When you get used to it, you don't have to draw the table anymore. Let's see. Okay. So from kilometer square to meter square, we know that it is 10 to the 6. All right. But from meter square to micrometer square is 10 to the 12. Okay. So well, I guess I don't have to draw the table. So it means that 2.5 kilometers square is actually 2.5 times 10 to the 6 times 10 to the 12, which is 2.5 times 10 to the 18 micrometer square. So this answer is in exponential form. If you want to convert it into number non-exponential form, then you see that there will be at least 17. There will be 17 zero after the decimal point. So I recommend that for the area metric system, you should use the exponential form. Like last time for the length metric system, you see that we don't have to use the exponential form, but because the number of zero is double, so that would be a lot of zero. So I recommend you use the exponential form. Okay. Now let's do another example. Example number 2 here. Now what if I want to let's say that I want to find the area of a circle, and we end up with the area of the circle is 4,534.36, 4,534.16 centimeter square. And I want to convert this. I want to convert this to let's say I want to convert it to which one do you want to convert it to? I want to convert it to how about gigameter square. Okay, so I want to convert to gigameter square. Okay, so let's see how we do that. Okay. Okay, so you know that the centimeter square, so centimeter square in this column right here, and you see that you go from centimeter square to meter square. So you have for 0 in meter, you have 10 to the negative 4, and you keep going to the left hand side. So you will have from here to here, you mean 10 to the negative 18 from meter square to meter square. Then we have 10 to the negative 18. So 10 to the negative 4. Okay, so the answer would be 4, 5, 3, 4, 10 to 16, 10 to the negative 4 times 10 to the negative 10 to the negative 18. Okay, 10 to the negative 18. So the final answer would be 4534.16 times 10 to the negative 22nd gigameter square. Okay. Now if I go ahead and convert this to scientific notation form, so I'm gonna move three more decimal places to the left hand side. So it means that we're gonna have 4.53416. So we divide by 1,000 times 10 to the, so 3 decimals will be times 10 to the negative 19 meter square. So this is in scientific notation form. Okay. Let me see that we got it correctly or not. So this is divided by 1,000. Maybe you multiply by 1,000. Divided by 1,000 10 to the third. Yeah, so that's what it is. That's how you convert it to scientific. The scientific notation, I just want to quick recall. So scientific notation is always between 1 and 10. Okay, so that's just 4.5 over here, which is good. Okay, good. All right. So you see that with the table for metric system, area metric system, you see you can convert it very easily, right? You don't have to use the conversion factor because it does too many zeros, so you don't want to deal with conversion factor for area. Okay, you just use the table I show you here. Okay, and you see that meter and meter square for the length, the meter, and for the area is meter square, is the reference column. Okay, it's the reference, it's the main column where you can go to the right, okay, or you can go to the left hand side. Okay, All right. I think 2 examples should be okay. Let's say we can go ahead and find another one or not. Just give me a couple of seconds. I wanna maybe we should do one more, huh? Maybe we should do one more. So let's see. I can find one more, not? Okay. Okay. Hmm. Okay. Yeah, I don't have any other. Because the other one should apply the same thing. Um. How about if we go from? Yeah, I think it should be okay. I can. Or we can create a number. How about I want to go from micrometer square, and we want to go to picometer square. How about that? Okay, example 3. Convert 0.012 micrometer square to picometer square. All right, let's see how we do this. So we know that based on the previous system, we know that between nano and pico is -9, -12. So there are 3 more 0. Oh, and from micro to pico is about 6 more 0. You see that from 6 to 12, we go from left to right, right? So from micro to pico, so it'll be 6 more 0, 6 0 from here to here. So if you want to convert this, it means that you will have 0.12 you multiply by because it's 6, so you multiply by 10 to the 6, right? Because you go from left to right, you go from left to right, you go from left to right, you have positive exponent, so you have 10 to the 6. Oh, no, hold on, something wrong. So this is 10 to the 6, but this is for length metric system only. But now we do area, it means we gotta double that. So instead of 10 to the 6, we will have 10 to the 12. Okay, so we have 10 to the 12. So we have 10 to the 12. So 10 to the 12 picometer square. Okay, so you go from left to right. And now I want to convert it to scientific notation. So I'm gonna move the decimal over here. I'm gonna move the decimal, so you multiply by 10. Then you have 1.12 multiply by 10. Then you have 1.12, but you multiply by 10, you have to divide by 10. So 10 to the 12 divided by 10 will give you 10 to the 11 picometer square. Okay, so that is how you convert to scientific notation. Maybe in your homework they don't the MyMathLab homework is not gonna ask you to convert to scientific notation, but I still want to convert to scientific notation. It just kind of make a quick recall. Maybe some of you already know this, some of you already learned this, but you forgot. Well, yeah, but just a quick recall for you. Okay. All right. So after we know the metric system for area, so on the third part, we're gonna do metric system for volume metric system, and for this one we're gonna have meter cube. Okay. So this one meter square. Okay, now the reason we have meter cube because it's not square anymore, but we want to look at the cube. Okay, you want to, so volume is just actually the space inside a cube. So let me draw the cube for you. So the cube look like this. Okay, yeah, like that. It's not a perfect cube, but that's okay. Okay, so I have cube. Okay, and the volume is actually the space inside the cube here. Okay, inside the cube. All right, now inside the cube over here, I'm gonna put 4 subcube. No, not 4, 9 of them. So you have a cube up here, you have a cube here. So you have, okay, so you have the first cube, then you have another cube, then you have another cube here. All right, and there's 3, and you have another cube down here. Okay, and down here you have another cube. Okay, all right. So in here you have like, and this there are 3 more. There's a bunch more over here. So this is you see that we have 12 cube over here, right? 1, 2, 3, 4, 5, 6, 7, 8, 9. So we have 9 cube here, and there's another layer with 9 cube, and another layer with 9 cube. So totally, how many cube we have? So the total will be totally we'll have 9, so it'll be 27 cube, right? So 27 subcube. Okay, it's 27 subcube inside the space here. So this is just the first layer. There are 2 more layers. Okay, and the reason we have 27 because we just go ahead and count it. But actually, we can explain why I have 27 because if you look at this direction, we have 3 cube. Now, if we look at this direction, we also have 3 more cube, and we look at the vertical direction, we have totally 3 cube. So we can have 3. So this is 3 meters, 3 cube, which cube represent for 1 meter. 3 cube here, 3 meter, 3 meter here. So we have 3 meter times 3 meter times 3 meter. So totally we have 27 cube, which is 27 meter times meter is meter cube. So meter cube is the reference unit for the volumetric system. Okay. All right. So again, based on the prefix table, we can go ahead. Draw the matrix, the volumetric system. Okay, based on this prefix here. So we will have what? We have iota meter cube. We have zeta meter cube. We have hexameter cube. We have pentameter cube. We have gigameter cube. Yeah, okay. We have megameter cube. We have kilometer cube. We have hectometer cube. We have decameter cube. Okay. Then we have meter cube. Okay. Then we go down to decimeter cube, centimeter cube, millimeter cube. Then we have micrometer cube. And we have nanometer cube, picometer cube. We have femtometer cube, and we have attometer cube. Okay, there's two more, but I don't have enough space. So, all right. So this meter cube over here is the reference. It's a reference point right here, a reference column right here. So we have reference column here. Okay. All right. Now, you see, last time for an area, we have square. I mean that for each column, we double the number of 0, right? So from meter cube to the decimeter cube, we have 2 more 0. But now, for 1 meter cube, instead of double, we do triple. So we will have 1 meter cube is actually 1,000 decimeter cube. It will be a million. Okay, let me erase this color right here. Okay, it will be 1,000 decimeter cube, but will be a million centimeter cube, and will be billion millimeter cube. Okay, so we tripled them. Okay, so last time we know 1 meter cube, 1 meter is a million, right? 10 to the 6 micrometer, 10 to the 6 micrometer, and we double that for the metric system, for the area metric system. Then we end up with 10 to the 12. But now we triple for the volume. Then over here you will have 10 to the we triple them, so 6 triple will be 12 will be 18. Okay, we triple will be 18 meter micrometer cube. And if we apply the same logic, so last time we have what we have big on the nano, right? We have so nano meter is 90, 10 to the 9, 10 to the 9. We double that for the area is 10 to the 18, but now we triple will be 10 to the 27. Okay, 10 to this 27 nanometer cube. Okay, so 1 meter cube is 10 to the 27 nanometer cube. Okay, now if you again if you go from beta here, so we know the from beta to from beta meter to meter, we know that is 10 to the 15. 10 to the 15. So if we go ahead and triple them, think about if we go ahead and triple them, what we have, you will have 10 to the you triple them 45, right? Meter cube. That's crazy, right? So you triple them. You triple the number 0, and same thing over here. For the picotera, oh, I think I missed one of them, right? I missed one of the columns. So you can start from eta, then beta. So I missed there. I'm missing tera. Oops. Ooh. Okay. Let me Oh, I don't have enough space anymore. Let me go back so that we can fit a Terra over here. Let me erase that. Okay, so I'm missing the Terra. So this one should be Terra. Okay, then this one should be Beta. Okay, then we have XR right here. Okay, and then we have Zeta here. So I don't have a Jota. I don't have enough space, but you know the Jota will be here. Okay, so one beta is 10 to the 15 meter. Beta meter is 10 to the 15 meter. Now we triple the number of 0, so you end up with 10 to the 45 meter cube. Okay, and for Terra you will triple will be 10 to the 36 meter cube. For Giga will be 10 to the 27 meter cube. Okay, and for Mega will be 10 to the 18 meter cube. For Kilo, so you know 1 kilo is 30. You double for the area will be 60, and then you triple will be 90, so it will be triple will be 90, so 10 to the 9. And this is triple will be triple 18, triple 27 meter cube. There you go, and so on. Okay. So again, they apply the same rule. If you go from left to right, it would be positive exponent, and you go from right to left, it would be negative exponent. And of course, definitely your final answer should be in exponential form because there's too many zero over here. A lot of zero for the volume. So let me start with our first example here. All right, convert 3.28. How about if I want to go from I want to go from hectometer cube to millimeter cube. All right. So based on this table, okay, let's see. So from hectometers cube, so hecto will be hecto is 10 square. You treat with 10 to the 6. So you gotta go from hectometer cube to meter cube will be 10 to the 6. Because hectometer to meter is 100. If you do area, will be 10,000 will be 10,000, right? Then 10,000 will be right. So for hectare to meter is 100. Let me do a scratch paper over here. 100. Then you double. Okay, then you triple. Then you see that there will be 10 to the 6 meter cube. Okay, but we want to continue to go to meter cube. So meter cube will be another 10 to the 9. Okay, because you go from meter cube to meter cube. So your final answer will be 3.26 times 10 to the 15 millimeter cube. And this is inside scientific notation already, so I'm going to keep it like that. Okay. Good. Alright, let's do another example. Okay. Alright, what if I I say the volume of the cylinder pi r square h is let's see, I can go from a small number here. So I'm gonna go from is equal to 21.5 nanometer cube. Okay, I want to convert to let's say I want to convert to tera. Okay, I want to convert to tera meter cube. Okay. All right. First of all, we gotta go back to meter cube first. So we have 21. Excuse me. I have a bad allergy. Nanometer cube. Okay. Now we're gonna go ahead and multiply by, so nanometer cube right here. Okay, and nanometer cube, go to meter cube, you see that is 27. So this is multiplied by 10 to the negative 27, because you go from right to left. You don't put positive anymore, but you put negative. Then you continue, go from meter to tera, will be 36, right? So 10 to the negative 36. So your final answer will be times 10 to the negative 63, because negative 27 add to negative 36 is negative 63 terameter cube. And if I go ahead and convert to scientific notation, so you move decimal, means you divide by 10, and then you multiply by 10, so you end up with 2.15 times 10 to the negative 62 terameter cube. Okay. Pretty easy, huh? Not hard. Okay. And I want to mention another volumetric system. Instead of using meter cube, we have another unit. We can use liter. So if I apply the prefix table here, then you will have the matrices, the volumetric system for liter, another unit. Okay, so I'm gonna go ahead and create that table for you. So again, you will have, let me pull it down, let me pull up the prefix table. I need that. Okay. All right, then we have then we have liter, then we have jota liter. Okay, then we have zeta liter, we have esa liter, we have beta liter, we have tera liter, liter with the letter L, we have giga liter. Okay, then we have, so we have liter over here. Okay, with the L. Okay, then we have what, giga liter, then we have mega liter, then we have kilo liter, we have hecto liter, then we have decaliter, then we have liters as the reference column. Okay, and after that we have deciliter, centiliter, milliliter, then we have microliter, nanoliter, picoliter, then we have femtoliter, then we have attoliter. and so on. Okay. Now, the difference between this volumetric system and this volumetric system is this: from liter to deciliter, we have only we have only 1 0. Okay, we have only 1 0. So this volumetric system here is the same as length metric system. Okay, in terms of the number of zero. Okay, so you one over here, then you go from here to here, you have only 1 0. Okay, then you go from here to here, deciliter to centiliter, we have only 2 0, and we have 3 0 here. Of course, for the micro, we have 10 to the, we have 6, we have 10 to the 6. Okay, microliter. And over here for nano, we have 10 to the 9. 10 to the 9 nanoliter. And of course, you go from tera to beta. So beta, you will have 10 to the 15 liter. Okay, then over here, tera, you have 10 to the 12 liter. Then giga, you have 10 to the 9 liter. So you see that this kind is the same as the length unit system, the length metric system, right? And nothing different. For the mega, we have 10 to the 6. For the kilo, you have 10 to the 3rd. Okay. Okay, for hectare, you have 10 to the 2nd. For decaliter, you have only 10. Okay. And the rule is everything, every rule the same. You go from left to right, you have positive exponent. But in this case, you see that we don't have a lot of zero. So I don't recommend that you should use exponential form. For example, I can give you an example here. What if I want to convert centiliter? What if I want to do 128.5 centiliter to, let's say I want to go to megaliter. Okay, very easy. So 128.5. All right, you can put 128.5 in this the 0.5 over here, into centiliter right here. You can put at 8 right over here, the 8 right over here, and the 0.5 after that, because you always start counting from the decimal. Okay, so from centiliter to megaliter, how many columns we jump? 1, right? 1, 2, 3, 4. Okay, let's count again. Okay, 1, 2, 3, 4, 5, 6. All right, so jump 6 of them. So we're gonna move decimal places. So 6 decimal places to the left. Yeah, move to the left, right? So you're gonna have 128.5. Let's move it. Okay, we move the decimal place. Okay, 1, 2, 3. Okay, 4, 5, 6. All right, so let's see. We're gonna put the 0 over here. So you can have 1 over here already. So you have 0, 0. You have 0 and 0 and 1. And let me count again. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Okay. So the answer is 0.000128.5 megaliter. Megaliter, which is ml. Okay. You can use exponential form if you want to, but you don't have to in this case. Okay, you don't have to. All right, you just start counting from the decimal point. All right, so I already finished all the metric system for for area, for the volume, um, for the distance. If I have time, in the next video we'll be talking about the metric system for the weight. If we have time, otherwise maybe I'm going to jump to the next section. Okay. All right. Please watch the video carefully. If you have any question, please let me know. I'll be seeing you next time. Bye bye.